Hello everyone, myself Rupalakshmi, student of Sri Venkateswara College of Engineering. Today I am presenting on the topic Embedded System Software from the subject Microcontrollers and Embedded System. Before learning what are embedded system software, let us brief on what are embedded system. An embedded system is an electronic system designed to perform a single or a set of specific tasks. It consists of three parts: hardware, software, and mechanical components. In an embedded system, software plays a crucial role in driving and controlling the system's hardware. The software stack in an embedded system typically consists of multiple components, each operating at a higher level of abstraction to provide separation between the core functioning and the underlying hardware. The initialization code is a set of initial instructions executed on the embedded system when it is powered on. The code is to specify the particular target or a group of target the system is designed for. Its primary purpose is to configure and set up the essential components of the board before handing over the control to the operating system. The four main software abstraction layers on the hardware are initialization, device drivers, operating system, and application. The initialization code in an embedded system is responsible for taking the processor from the reset state to a state where the operating system or other software can run it. It performs several essential tasks, including configuring the memory controllers, initializing the processor caches, and initializing various devices. In simple embedded system, the operating system may be replaced by a lightweight alternative such as simple scheduling or debug monitor. These monitors provide basic functionality for task scheduling, debugging, and other system level operations without fully complexity of a traditional operating system. The first code that is executed on the board when the device is powered on is referred as the boot code. This code is typically stored in read-only memory and is responsible for initializing the system, configuring the hardware, loading the operating system into the system's random access memory. The initial hardware configuration phase, the target platform is prepared to boot a specific image. While the target platform may have standard configuration, modifications are often necessary to meet the requirements of the specific image being booted. The standard configuration of the target platform typically includes default settings that are suitable for a broad range of applications. However, certain features of the configuration may need to be modified to ensure compatibility and optimal performance with the specific image that will be booted. These modifications can include several features including memory configuration, device initialization, interrupt handling, clock configuration. By modifying the target platform's standard configuration to match the requirement of the booted image, the hardware is prepared to provide the necessary resource, interface, and functionality for the successful execution of the image. Diagnosis code embedded within the initialization code serves the purpose of testing the system, identifying any faults or issue. The diagnostic code exercise the hardware components of the target platform to check if they are in proper working condition and detect standard system related problems. The testing performed by the diagnostic code is important, particularly during the manufacturing phase when the software product is considered complete. By executing various tests and checks, the diagnostic code helps to ensure the hardware components are functioning as expected and the system is reliable and in operation state. The primary purpose of the diagnostic code is to fault identification and isolation. It aims in detecting any issues or failures of the hardware components or the overall system. The diagnostic code may perform tests such as memory test, communication interface checks, peripheral functioning test, and other relevant hardware specific tests. When a fault or issue is identified, the diagnostic code typically includes mechanism to isolate and localize the problem. This allows for pinpointing the specific component or subsystem that is experiencing the fault. By identifying and isolating the faults, manufacturers can address them approximately whenever it involves repair, replacement, or further debugging and analysis. In boot process, loading an image is an essential step before handing over the control to that image. This image refers to the executable code and associated data that constitutes an operating system or application. The specific details of loading an image can vary depending upon the system and the nature of the image being loaded. The image loading process during booting includes locating the image, loading the image into RAM, compression is an optional step, image decompression, handing over the control. The complexity of the boot process can indeed increase when booting different operating system or different version of the same operating system. This is because each operating system or version may have its own specific requirements and configuration. The boot loader needs to handle these variations, including selecting the appropriate image, ensuring complexity, and managing the loading and execution process accordingly. A device driver is a software component that serves as an interface between the operating system and the hardware device in the computing system. It enables communication and interaction between the operating system kernel and the hardware peripherals. The key features of device driver are bridge between operating system and hardware, information exchange, connecting and initialization, data transfer, and error handling management. Device driver play an important role in enabling the operating system to effectively manage and control hardware resource, the abstract the complexity of the hardware and provide an interface for application to interact with. By encapsulating the hardware specific details, drivers allow application to be written in more hardware agnostic manner, making them to portable across different system and hardware configuration. Embedded operating system are specialized operating system designed for specific tasks in non-computer devices. These operating systems are typically tailored to meet the requirements of the embedded system and enable it to perform its intended function. Regarding the categorization of operating system, there are indeed various categorization schemes. One of the most common categorization is real-time operating system and platform operating system. Under real-time operating system, we have hard real-time operating system and soft real-time operating system. It is important to note that embedded operating systems can fall into both the categories. Some embedded systems require real-time capabilities and would use real-time operating system to ensure precise timing and task execution. Others may utilize a platform operating system if their requirements are less time critical and they benefit from the broad software ecosystem and development tools provided by the platforms like Linux and Windows Embedded. Real-time operating systems are designed to handle real-time applications where tasks must be completed within a specified time constraint. Real-time operating systems provide deterministic behavior, prioritized task scheduling, and precise time control. They are located between the hardware and the application software. Hard real-time operating system guarantees that critical tasks are always executed within their specified deadlines. Failure to meet a deadline can lead to catastrophic consequences. The application that required hard real-time operating system includes aircraft control systems or medical devices. Soft real-time operating system prioritize an attempt to meet timing constraint, but occasionally deadline misses are tolerated. These systems are commonly found in multimedia application, robotics, industrial automation, where occasional time delays can be accommodated without scientific impact. Platform operating system, also known as general purpose operating system, are designed to run on a wide range of computing platforms including personal computers, servers, and mobile devices. They provide a comprehensive set of service and functionality to support a broad range of applications. Examples for platform operating system includes Windows, Mac OS, Android, and iOS. The role of the operating system in scheduling application and providing an environment for their execution is important. The operating system manages the resource of the system and coordinates the execution of multiple application or tasks. ARM processors are widely used in architecture in embedded system domain and are intended to found in various market segments and application. ARM-based processors are known for the power efficiency, performance, and versatility, making them suitable for a wide range of device and industries. Here are the few more application of embedded system software domain. Thank you.